Let's discuss question number 37 from test 2. This is from fluid mechanics, fluid statics basically. So you have a cubical tank 6 meter by 6 meter by 6 meters, half filled with water. So let's draw the cross section. This is half filled with water and the other half you have oil. So let's focus our attention on this wall. So this wall is something like this, where at the start you don't have pressure, and because of the oil, so you have some pressure which is exerted like this. Okay, so this is the interface. Let's say that the interface the pressure is P1. Okay, now after that the density is more and the pressure diagram looks like so. Basically what we are doing is we are drawing the pressure. So here the slope changes. I mean, initially if it would have been straight, it would have gone like this. This is the pressure. So at here it is P1. So let me just write, this is A, this is B, this is C. So this is my P2 at this point. So this is on due to the water section and this is due to the oil section. So what we will do is, because this is half, so this is 3 meters and this is 3 meters, and so this is your cross section and the pressure distribution is same perpendicular to this cross section. So ideally it is something like this throughout that trapezium with one water, and then it is something like this. Okay, so you have the oil trapezium and you have the water pressure distribution. Okay, so now the volume of the trapezoid gives your the total force, total hydrostatic force, or the total pressure force. Okay, trapezoid. So first let's see if I individually find out P1. So P1 is rho of oil into G into H, H1. Rho of oil, specific gravity is given, so specific gravity into density of water. Specific gravity is always expressed, I mean the density of any liquid by density of water is the specific gravity of that liquid into G into H1. Specific gravity is 0.8, density is 1000, 9.81, H is 3. So let's calculate this pressure. So this value comes out close to 23,544 pascals pressure at P1. Now pressure at P2 will be your pressure at P1 plus, now the water column, weight of the water column will produce some pressure, so that is rho G H2. So pressure is 23,544 plus water is 1000, density 9.81 into 3. So this pressure comes out to close to the total value 52974 pascals. Okay, so you have individual pressures. Now you need to, this cross section is this basically whatever I have drawn. So you need to basically find out the volume of the trapezoid because of the oil plus volume of the trapezoid because of the water. Okay, so volume of the trapezoid AB, so let me call this as T, this is E. So volume ABD plus volume PDEC. So ABD, I can just, it's basically half P1 into length 3. I mean this is triangle, right? So half 3 into BD, which is P1, that is the cross section. Now into perpendicular depth is again 6. So that is your ABD volume. So now volume of the trapezoidal BDEC is trapezoid. So half mean of BD plus CE into your height PC, which is 3, into your perpendicular depth, which is 6. So half P1 is your half P1 into 18, and this is half P1 plus P2 into BC is again 3 into 6. So this comes out to be 9P1 plus 9 P1 plus P2. This comes out closer to 18 P1 plus 9 P2, and this value, let's find out, comes out, so 18 P1 is 23544 plus 9 P2 which is 52974. So this comes out to closer to 900558 newtons. It's 900.55 kilonewtons. So roughly close to, you can say, 900 kilonewtons. So the answer is 900 kilonewtons. Option is C. So it's basically the volume of the trapezoid. One of the length, one of the side of the trapezoid is basically formed by the pressure. The other sides are all length. So this is how you have to build and construct. So once get the pressure, and then it's just basically volume calculation. So option is C. Thank you.